Hello. 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 Hello, Meeta.
Hello.
Yeah. Is it audible?
Yes.
Thank you. Oh, after so long time, you are so much busy. I don't know why you are so much busy. Okay, okay, okay. So let us try to start our topic. Up to Bohr's atomic model we completed. Yes, now?
No, we did more, I think.
You see?
Oh, yeah, no. We get up to Bohr's, yeah.
Okay, okay. So what we are doing, that is the Bohr's atomic model. Some point he said that is the electron distributed. Okay, distribution of electron, actually he told distribution of electron. How he is told about distribution of electron, you can see. That is 2n square root he gave. That is what? 2n square root. 2n. N means he said that is orbit number. N means orbit number. Orbit number, he said that is it can be K, this is L, this is M, this is N. They are there. K means that is first orbit, this is the second orbit, this is third, here is fourth. If it is O is there, so this is going to be 5. If P is there, this is going to be 6. So if someone is asking that is how many electrons are there in the fourth orbit, so what will be your answer? Number of number of maximum electron. What is the answer?
32 electrons.
2n square means 2 into 4 square. That is exactly, that is the 32 electrons. So that you got to know. Now, actually, what the up to Bohr's, what they said, that is here the circular orbits are there. Okay, and in these orbits electrons are there, right? They said that is this, in this orbit electrons are there. Yes, yeah, no.
Yes.
Now, but in the present time, what we got, that is present time, when the mechanical model came, or you can say modern concept came. So electrons are present in where? Electrons are present in where they are going to present in orbital. This is the concept here. Electrons are present in orbital. Getting my point? Not, they are the circular path. Orbit means what? That is, you got to know orbit
Oh,
means.
yeah.
This is the circular path, right? Circular path.
Yeah.
But what is this one? Nowadays, this is not the true. Electrons are present on the what? That is called the orbital, not the orbit. Getting my point?
Oh, okay.
Okay. So let me firstly, can I erase this one?
Yeah.
Okay. So now if you see, that is, first of all, let us know, clear our mind, that is the, what is the meaning of orbit and what is meaning of that is orbital. Getting my point? Orbit and orbital we are going. So if you talk about the orbit and orbital, so if you see, can you tell me the orbit? Already I told you orbit.
The circular path.
So this is the circular path. This is circular path, right? Circular path. Okay, and what the point they are saying, circular path given by, if you say who give this circular path, that is Rutherford also said the same point. Rutherford and Bohr's both uses the circular path, BOHRS. Okay, BOHRS. This is the point. Now orbital is what the different concept. Okay, this is the important one. So orbital is what the point they are saying, you keep in mind. Orbital is three-dimensional space. You can write orbital is three-dimensional space. Three-dimensional space. Three-dimensional space where they are saying where probability of finding electron, probability of finding electron is maximum. This is what the definition, finding electron is maximum. Means Means what the point they are Rutherford and Bohr were saying, that is electrons are moving on circular path, that is the very different, but they are moving to, so you cannot find the exact position, okay, because they are moving. So what they are
Yeah.
saying, that is the now concept came, modern concept came, which is the orbital concept. Okay, and what the orbital concept is saying here, you can understand, that is orbital is three-dimensional space, or a three-dimensional space where WHERE, where probability of finding electron is maximum. So means there is the probability of finding electron. It is not actually present at the certain fixed position. They are continuously moving. So moving, they are not moving on the circular path only. They are moving on the 3D path, because the structure of atom is spherical same. So that is electrons are moving on the circle, that is 3D path. Getting my point?
Yeah.
Okay, so these are the first point. If I will ask you, that is, can you tell me how many types of orbits are there?
So 2.
No, circular orbits are there, but how we are denoting? How we are denoting?
I don't know.
A, L,
Oh.
M,
Oh, right. Okay. Yeah.
M, and they are the means the circular path. There are so many orbits are possible around the nucleus. Okay, so they suppose this is the nucleus, so that is they are the orbits are there. Okay, just like here. But here, if you talk about orbital, the second point here, you see orbital. Okay, if you are going orbital, if you talk about the orbital, so it is orbital. Orbital is how much? Four types are there. Okay, orbitals are four types. Orbitals are four types. Four types. Okay, this will be helpful not in your the first year. It will be the helpful for the second year also. Okay, this much detail is not there in the first year, but I want to make it, that is the chain. I want to make the clear chain. So that is after the Rutherford model, you should know some more information so that we can study later on. So the same time we are preparing for the second year also. Okay. So
Okay.
so orbital are four type. Orbitals are four types. What are these four types? See this one we are writing, that is s orbital. You please keep on writing also. And here
Okay, yeah.
another is the p orbital. This is the p orbital. Next one is the d orbital, and the last one is f orbital. F orbital. See, so this is the three-dimensional are there. This is so orbit concept are there. That is only they are the K, L, M, N. They are there. Very. This is the circular path. Very easily you can remember circular path. But when you talk about orbital configuration, orbital, so it is very different. What are there? That is s orbital, p orbital, d orbital, f orbital. Now let us keep one more point here. The first orbit, how many electron you told me? First orbit, how many electron?
2,
Oh,
right?
2. Thank you very much. Second,
8.
8. Third,
9. 18.
how much? How much?
18.
18. 18. Thank you. Next one,
4 squared. 32.
32. And last one more you can tell me.
50.
50 electrons. So thank you. So these are there. Now see, they are the orbital. Now we are going to study little bit more deeper here. So I am going in the next page. Can I go next page?
Yeah.
Okay. So see here the orbital concept. We are going orbital here. So if you talk about the s orbital, s orbital. So s orbital is spherical shape. Spherical shape. This is the spherical shape. Only one type. Only one type. Only one type. Okay. Only one type. One type orbital. One type orbital. One type of orbital. This is the very orbital punchline. One type of orbital can have maximum 2 electron. This is the star mark. One type of orbital can have maximum 2 electron. So it is only one type. So how many maximum electron can be?
2 electrons.
2 electrons. Very good. So this is 2 electron. So I am representing it like that. 2 electron. always two electron present in the, one is clockwise, another is anti-clockwise. This is okay, and this is the spherical shape of what it is going to be, s orbital. So whatever the dark one is coming when you study the photochemistry or the spectroscopy, so that you will be able to observe the orbital. Orbital means how the orbital appear actually when you keep the sample in the photo spectroscope. So that is some shades come, some shades are coming. The spherical set is coming means the s orbital. Okay, so that is what the s orbital. Now we are going for the p orbital. P orbital, if you talk about, this is the dumbbell shape. Dumbbell shape. Dumbbell shape. Dumbbell shape, you can, so that is what we practice now. Dumbbell. That is the that one, dumbbell shape. Can you be able to understand dumbbell?
No, what is, I didn't understand what
Dumbbell,
dumbbell
that
is.
is in the gym, na? Gym.
Oh, okay, okay. Yeah, okay.
That dumbbell shape. So dumbbell shape. And second point, they are saying three types. They are saying three types. Three types. So if three types is there, so one type can have maximum 2 electrons. So three types have how many electrons?
6 electrons.
6 electrons. Thank you. So 6 electrons. 6 electron means three type I am making here. That is 1, 2, 3. So p orbital is there. So it is called px. Another is called py. Next one is called pz. So I am mentioning the electron. So electron field 1, 1, 1. So 1, here is 2, here is 3. Then it is going to be 4. Here is going to 5. Here is going to be 6. This one. Now if dumbbell shape, if you are making this one, so let us have a look over this one. This is the x-axis. If orbital lobes, if dumbbell is on the x-axis, so this is called px. Okay. If the dumbbell is on y-axis, suppose this is the y-axis. Okay. So y-axis, if the dumbbell are there, lies on the y-axis, so this is going to call py. And if the dumbbell is on the z-axis, this one, so this is called, that is z, pz. So this is what z orbital. Okay, this is called pz. So these are the shape of the s orbital, and then we are going for the p orbital. Can you be able to understand this one?
Yeah, but I don't really understand the opposite, that they have to go in opposite directions. I didn't get that. The arrow.
Electrons, what they are saying, suppose they are saying that is, suppose the same direction are there, na? Suppose here, see, if s orbital is there, s orbital, so electron is going the same direction, na? Same. So they are saying that is, if they are having the same direction, they will strike. Why? How they will strike? Some point of time they are going to strike. But here they are saying if they are having opposite spin, because they are moving now opposite spin. So they are moving like this. They are moving like this. Getting my point? Their electric field will be like this direction, and its electric field will be this direction. You know, electron produce the electric field in the physics. You may be knowing.
Yeah, yeah.
Every charged particle has its own electric field, right? So and electric field is having the direction, okay, positive to negative. So here they are saying that is, if they are having the same direction now, so they are going to strike out. So two electrons would have the, one is the positive spin, that is plus half, another is minus half, 1/2. Getting my point?
Yeah. Okay.
So in one orbital, two electron will be there, but that should be opposite spin. So again, you will study the Pauli exclusion principle. This much detail is not there. Okay, so that I am not going very detailed. I'm just trying to make your interest continue. Okay, that is why I'm teaching you this one. Okay. So next one, you go the next one, d orbital. You drawn this one, s and p orbital.
Yes.
Okay, so I'm erasing this one. Okay.
Okay.
Now, so that is the last one was there in the orbital. Two more orbital are there. That is d orbital. This is the another is third type is d orbital. D orbital is, this is called, that is double dumbbell shape. This is the double dumbbell shape. This is the double dumbbell shape. Double shape means two dumbbell will be there, and 5 types. They are going to be 5 types. Okay, 5 types. So can you tell me the maximum electron how many?
10 electrons.
10 electron. So 10 electron we can mention here, it is like that. Okay, 1, 2, 3, 4. So one is called, that is dxy. Okay, another is called dyz. Next one is called dzx. Another is called dx square minus y square. And last one is called dz square. Okay, this one. So 10 electron we are filling. Firstly, one by one we have to fill. It is a very simple. When you are traveling in the train now, it is traveling in the train. What you try to do, you try to sit one by one. In the night time, what you do, you try to sit one seat, one person. Yes or no? In the same one, if it is not reservation, so you can find that is one person without reservation, one person try to sit one seat, so that easily you can go now. Suppose it all the seat is filled, so what there will be there will be pairing. Yes or no? Two will they will start setting. So simply this electron is also having, firstly electron go in each orbital 1 1 1. So 1 2 3 4 5. Then 5 filled means then they have to go paired up. So they are going to paired. Getting my point?
Okay, yeah.
Okay, simple in the school also. If there is the branches are there, table are there, you are knowing not going to sit 4 5% at the same. What you do? You try to sit the no, one person one branch, because so that
Yeah.
you will be the feel the, you will feel that is little bit comfortable. Yes or no?
Yeah.
So the same electron also having the same. If the two so many electron coming in the same orbital, so it is the will be repulsion. So that they are going to be what? That is the firstly one electron, then they are going to pair. Up now, will it be okay to you? Are you be able to understand? Okay, good.
Yes.
Okay. So now the 5 type of d orbital, I am making the diagram of it. You can try to understand this diagram also. Okay, and you try to draw also. See, so if I am talking about, this is, suppose this is the x and y are there. So if one dumbbell is there between x and y, another is dumbbell is there between x dash and y dash. See, this is the called x dash, and this is called what? Y dash. So this is called, okay, no need to mention this one x dash y dash, you may be knowing, because you have taken, you will going to take the, in the HL, mathematics will be your core subject, no? No. So which one, which one will be the which you are going to take as a HL?
I'm taking biology, chemistry, and economics.
Okay. Okay.
Math is standard level.
Okay, good, great. So let's have a look. So it will between the x and y, dumbbell are there between x and y. So its name will be xy. Okay. Suppose I'm making this axis y and this axis z, and this is the lobes are there, that is dumbbells are there between y and z. So name will be what? D orbital. So d y z. If suppose this is the x and this is going to be z, and this the orbital are there, where they are orbital between x and z, so this is called, that is dxz. Now you go for this one. If the orbital are like that, if the orbital are like that, if x and y, if the orbital are along the axis, not the between the axis, so it is called dx square minus y square, because the lobes are there along the axis. Here that is the lobes you see, where between the axis. Yes or no?
Yes.
Between the axis. But here if you talk about here along the axis, so it becomes the square. Another is there, if you talk about this is the z, so what we are going to do here, that is this one. So this is what, that is dz square. So they are the, this will the along the axis, lobes are along the axis. If you are talking about orbitals are along the axis, yes or no?
Yeah. Okay.
And orbitals are between the axis. Now I think orbitals are between the, I think it will be okay to you this much. You drawn this one?
Not the last one.
Okay, you draw please. A4.
Okay, done.
Okay, last one is diffused shape. Diffuse shape means what? Can't be drawn on paper. Can't be drawn on paper. You cannot draw on paper. That is what the diffuse shape. How many types? 7 types. So can you guess how many electron will be there? Total?
14 electrons.
14. Thank you so much. 14 electrons. Okay, your concentration level is quite too nice. That okay, you keep the same rhythm throughout the class. It's a great one. Okay, here you see. Here is a 1, 2, 7 type will be 1, 2, 3, 4, 5. Here one we are increasing 6, and this side again we are increasing one more, that is 7. So this is the 1, 2. Here is 3. This is 4, 5, 6, and going to be 7. Here is 8, 9, 10, 11, 12, 13, and 14. This is the F orbital. This is the concept of orbital. Can you be able to understand this one?
Yeah.
Okay. So I am erasing this one. That F orbital also you need to write. Done?
Yeah. Yeah.
Okay, good. Now, up where we are going, that is electronic configuration. Electronic configuration. Okay, this is I am teaching you electronic configuration. Of electronic meaning of electronic configuration, you see, distribution of electron, distribution of electron in various orbital, distribution of electron in various orbitals. Okay, various orbital. A in increasing order of, in increasing order of, see, in increasing order of energy of orbital, increasing order of energy of orbital, energy of orbitals are known as electronic configuration, are known as electronic configuration. What is the point here? You see, that is this one, you say that is s orbital, that is here I am writing maximum electron, and here is the orbital, right? So s orbital is there. If you talk about the s orbital, here is s orbital. So how many maximum electron is going to be? 2. P orbital. So p orbital, how many are there? Can you remember?
6 electrons.
6 electron. Thank you. D orbital.
10 electrons.
10 and 14 electron. Thank you.
Yeah.
Good. Okay. So here you see. So these are the distribution of electron. How many are there? S orbital 2 electron, P orbital 6 electron, D orbital 10 electron, F orbital 14 electron. Minimum can be 0. Minimum can be 0, 1, whatever. This is. Now, what the point which we have to understand? Energy order of orbital. Okay. If I am writing, that is energy order of orbital. Energy order of orbital. See, what is the energy order of orbital? You see. So firstly, that is 1s is there. S orbital. 1s means that is 1s orbital, s orbital. First, one. If I am writing C, 1s. So this one is implies that orbit number. This implied that orbit number, and this is implies that orbital. Okay, orbital. So keep in mind that is orbit is also existing, but in the orbit there is orbital is also existing. That you need to keep. So 1s is there. Then they are saying that is 2s. Then they are saying that is 2p. Then they are saying 3s. Then here is 3p. Then they are saying 4s. Then this is 3d. Then it is going to be 4p. 4p. So they are the increasing order of energy of orbital. Here is increasing order of energy of orbital. Energy of orbital. Is it getting very difficult to you, Mika? Is it getting difficult?
A little bit lost. So the number in front means orbit number, and then
orbit number.
The letter is which orbital.
Orbital.
So how does the orbit number influence the energy?
If you write this one, then I will write.
Okay.
You complete the writing work, then I will tell. Okay, very nice. You are asking the question. That is very great.
What is the last one on the energy order? Is it
4p.
okay?
There will be many more, but I am writing very few one.
Okay.
What means I am giving you the trend. Okay, if you know the trend,
Oh.
it will be easy going for you. Later on, you can understand easily by your own also. Is done?
Okay.
Done now?
Yeah, done.
Okay. See, they are saying that is orbit. There are so many concepts actually. That is, yeah, we cannot be very simplistic in chemistry. There are so many concepts are there, and it is too much mysterious are there. The more you study deeper, the more the interest will generate. So here orbit are there. Orbit is called cell. Okay, this now the new term come. So you will say, this sir, what you are teaching, so many terms are coming. Okay, orbits are called cell. Then orbit is split into what they are saying, that orbit not orbit, that is cell is split into subcell. This cell is splitting into subcell. A subcell is called orbital. This is it means that is the one orbit can have many orbital. Okay, one orbital can contain many orbital. Let's try to understand in different ways. Suppose orbit number, it can be the k, if it is k, then l, then m, then n, then o. So many will go. O, p, 7 are there. 1, 2, 3, 4, 5, 6. No, wait, let me reduce. Then again, let me rewrite, because 7 we need to write. So that is, this is the k, then it is l, then is it going m, here is n, o, p, q. So I think 1, 2, 3, 4, 5, 6, 7. Okay. So first orbital, if you are going, so it is having what? Only one orbit. It is divided into only one type. The first orbit, if you are talking about, this is k means 1, l means 2, m means 3, this is 4, that 5, 6, 7. Getting this already you know. K cell means the first orbit, l means second orbit.
Yeah.
Okay, m means third orbit, o means fourth orbit, p means sixth orbit. This is 7. Is it okay?
Yes.
So k orbit is only one type, 1s. If you are going l, so l is also having what? 2s and 2p. So these two are implies that this is orbit number. Getting?
Okay, yeah.
Third one, if you are going, it is going 3s, 3p, and 3d. If you are going 4, so it is coming to be 4s, 4p, 4d, and 4f. Next one, if you are going O, this is called 5s, 5p, 5d, 5f. Next one, if you are going 6s, 6p, 6d, that one. 7s, 7p. Up to this much is there. That many orbital exist. Out of this 180 element, with the help of this 118 element, can be filled easily. 118 electron, you can say. Okay, now
Okay.
how can you make this one? Let me try to do. You are going to start from here. Okay, diagonally we have to start. So 1, then 2. Okay, then you need to go. This one is going very straight. You need to go. So you see what is the firstly coming 1s, then it is coming 2s, then it is coming 2p, then it is coming 3s. Okay, after 3s, which one is coming? 3s, then 3p, then it will come 4s. Yes, yeah, no. So
Okay,
this
yeah.
is 3s, then it is coming 3p. Then you see 3, then 3s 4, no, 3s,
Yeah, yeah.
3p,
I
then
got it.
4s.
Why is
And
there no, for example, like in the second shell, why is there no 2D or 2F? Why does it stop at P?
only maximum. Second cell, how many maximum electron? Second cell, maximum electron, how many are there? Maximum electron, 8. So second cell, how many? We are going 2s, 2p, 2s, 2p. So s orbital maximum electron, how many will be there?
2 electrons.
2. P orbital?
6.
6. 2, 6, how many getting? 8.
8. Ah,
You are
okay, okay.
if you are rating the D enough, it will become 18. That is not possible. Second cell
Okay.
is the 2 only. Second cell means 8 electron. Getting my point?
Yes. Okay.
Okay. Keep on asking, please. It's feel very much pleasure that wherever you are facing the doubt, you are asking. Because some other student, they don't ask, even though I know they are not understanding, but I can't do now. They are effortless.
Yeah.
Hmm.
Effortless.
Yeah, means if they are not asking, and I know that they are not understanding, and they if they are not asking, if I will teach now, they will not get that one. Okay, you need to make your mind very much active. Okay, so if your
Yeah.
mind is active, so that you can think on it and you can ask the problem. Okay,
Okay. Yeah.
so this is the energy order. I wrote, you asked little bit, I explained too much. Here you can see that is I went all the orbital. Here I got 4s. After 4s you can see 4s, which one will come? 3D will come. Yes, now this one
Yes.
4s 3D. Then which will come? 4p will come. 4p. Then which is going to come? 5s. This is going to 5s. Next one which is coming? 4D. Next one you see 5p. 5p. Okay, next one you can see 6s. Next one you can see 4f. 4f. Next one 5d. Next one 6p. Next one 7s. The last 5f. Then it is going to be 6d. Then it is going to be 7. This is the increasing order of energy of orbital. This is called above rule. It is the rule is there. Increasing order of energy of orbital. But it will come in the next year. This year not given in your book. Next year it will come. But it is why I'm teaching, because it is connected, interconnected. That is why I'm teaching. Because next year if I will start teaching, so you will say that is again you explain orbit and orbital. But this year I am explaining this one little bit deeper. So next year automatically when teacher will teach, you yourself can be able to understand. So increasing
Yeah.
order of energy of orbital. Energy of orbital. Orbital. This is according to, this is the rule is there. I'm writing the rule name also. This is the American scientist. According to A doubles. According to above rule. AUFBAU. Above rule. This is given by above rule. There are many more rule are there, but that we will study later on where required. So okay, you wrote this one, completed?
Yeah.
Okay, so what I'm doing, I'm erasing some part of it. Which pan part? Let us erase this one. Then I'm writing the electronic configuration of the.
Okay.
Yeah. See, I am taking the hydrogen, then helium, lithium, sodium, wait, lithium, then it will come lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So here you can go 1, here is this is 2, 3, here is 4, here is 5, 6, 7, 8, 9, and 10. So if you are talking about hydrogen, so hydrogen means these are atomic number, means number of electrons. Simple. If there is no charge, neutral atom is there, atomic number means number of electrons. So only one electron is there. See, one more point, denomination I want to write. Let me write that here. What is the denomination? If anything is there, 1s, okay, and here is, suppose I am writing 2. So top is number of electron. If top of orbital, what is representing? Top or orbital represent what? Represent number of electron. And this one, what is the number before? What it is representing? Orbit number. And this is representing, this one is orbital. You can say in bracket, also you can say subcell. Is it okay? Can you be able
Okay.
to understand? So see, hydrogen is having how many electrons?
1.
One electron. So here is 1s, that is 1 electron means it is going to be top. 1s1. Can you be able to understand this one?
Yeah.
Second one, the 1s, it is going to be 2, because s orbital, last page already you wrote, s orbital maximum 2 electron, p6, d10, 14. So 1s is 2 electron filled, then it will go next one. So is it okay? Helium 1s2.
Yeah.
Lithium, if you are going, that is 1s2. Then the s orbital maximum 2 electron now, so this is filled. Then next one, which orbital will come?
P, right? No. Yeah, P.
See here, see. After the 1s, which will come after
Oh,
1s?
2s.
2s. So it is coming 2s. The 2 out of 3 electron, 2 is filled here. So how many left to
One
fill in? 1 electron. Thank you. Okay.
Okay.
Now go for
Yeah.
beryllium. So beryllium, this is the 1s2. Then how many
Yeah.
electron will go in the 2s?
2 electrons.
2s2. Thank you. Now go for the boron. Boron.
So
Can you?
1s2,
1s2,
2s2, and 2p1.
2p1. Oh my God. Tell me for the carbon.
1s1, 2s1, no, 2s2, and 2p2 as well.
2p2. Great. Nitrogen.
1s2, 2s2, and 2p3.
Great. Oxygen. 1s2, 2s2,
2s2, and 2p4.
2p4. Fluorine, if you are going 1s2, 2s2, 2p5. Okay, 1s2, there is 2s2 and 2p6. This.
Yeah.
Mika, can you share the books? If you can share the book, if you are having the free time, what you can do, you take the pic and please share to me na pages of your book.
Which chapter?
The same chapter, atomic structure we are studying now, the same chapter.
Okay.
Because
Okay.
whatever whatever I am teaching, everything should go to you. If suppose any topic is left behind, nothing is use of that study. Just I want to teach you each and everything. So if you are sharing your books na, so I may see the content also. Okay. Because whatever I am teaching for the other book, that is some other student are studying, that book I will tell you name of that book. What is this? Something is there. Okay, you wrote this one. Mika, done this one?
No, I'm not done.
Okay, please write down. I am telling you the book name. Otherwise, you can ask from your mom, see if she is knowing to use the Google Drive. Also, that way you can share the book to me also. Google Drive.
Okay.
In the Google Drive, you can upload and then you can share the link to me so that I can easily download. Google Drive.
Okay. Yeah.
I am having, what is that? Edexcel International, GCSE 921 Chemistry, Jim Clark, Steve 1. These books I am having. So this book is quite okay.
I have it.
Done.
Yeah.
Okay. So this is all about the electronic configuration. This is actually given this much only in the atomic structure. This much information is given. I have given some more information. Let us try to understand what other things are there for your first year. So I am erasing this one. First year there, the isotopes are there. Isotopes. What is isotopes? Can you tell me what is isotopes?
It's like the same element, but
Good. Super.
I'm not really sure what the main difference is, but there's like, I know there's multiple isotopes of carbon, for example.
Yes, 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 yes.
Is it the way that the atoms are structured? I'm not so sure.
Yeah, yeah. Good, good, good. See, isotopes means iso means same. Iso means same. And topes, if you are talking about topes, topes means number, atomic number. Atomic number, atomic, same atomic number, right? So isotopes means what? Atoms of same element. They are the 3 point are there. Atoms of same element. Just like you say, na, carbon have many isotope. So atoms of same element. Okay. So same elements means same atomic number, same atomic number, same. But what the point they are saying, same atomic number, but what is the different? Different mass number, right? Different mass number, different mass number, right? So isotopes of atoms of same element, atoms of same element having same atomic number but different mass number. Example one. Example number one, that is isotopes of hydrogen. Isotopes of hydrogen. So if we talk about isotopes of hydrogen, three isotopes of hydrogen is there. That is 1H1, okay, then 1H2, then 1H3. Now see, you can see that is I already when I was teaching the earlier, I told you the upside is this is the mass. Yes or no? Mass.
Yeah.
This is again mass. And here is there the mass. Okay. And bottom that is what is there, that is atomic number. Yes or no?
Yeah.
This is also atomic number. And this is also going to be atomic number. Right. Now see, they are the atoms of hydrogen element. Yes or no? They all are the atoms of hydrogen element. Same atomic number 111.
Yeah.
Mass number is different 1, 2, 3.
Yeah.
So they are what? They are going to be isotope. Can you be able to understand?
Yes.
Please make a note of it.
Done.
Done. Thank you. Now, let me try to. This all the things you wrote, na. This one also, na.
Yeah. Yeah.
Okay. Now, example number 2. Isotopes of carbon. Isotopes of carbon. So isotopes of carbon, there are no. Acha, this one name are there. Yeah, I forgot. The one is there, na. This is called protium. Protium. If mass is 1, that is called protium. Second one, 2 is there. This is called deuterium. T-U-E-U. Deuterium. T-E-U-T-E-R-I-U-M. Deuterium. Okay. This is used in the nuclear reactor. And last one is tritium. Tritium also they can call. In foreign they call tritium, but we call tritium. Then next one. So isotope of carbon, that is carbon is also, that is 3 isotopes are there. Carbon 6 and here is what is there 12. Okay. Then carbon here is 6, this is 13. Carbon here is 6 and this is 14. So what you are finding, that is the point number 1. Atoms of same element carbon. Atoms of what? Same element carbon. Yes or no? Atoms
Yes.
of same element carbon. Point number 2. Point number 2, what we need to write?
Different mass number.
Same atomic number, but different mass number. Same atomic number, but what is there? Different mass number, but different mass number. Different mass number. So if this is happening, so that is they are known as what? Isotopes. Can you be able to understand this one?
Yep.
Okay. Can I erase this one?
Yeah.
Completed?
Yes. Yes.
Heading isobars. Iso. First point. These are there in the syllabus. Okay. This is there,
Okay.
the IB curriculum. I know this is the first year only. That is, you need to remember this one. Isotopes and isobars are there. You check the syllabus also. Okay.
Okay.
You yourself has to be very much active, that what the teacher need to teach, how much there in your book, that must be reached to you. Okay. uh, Teacher may sometime may misguide you, that okay, this is not there, this is there. No, this is the book. If it is there in your book, that you go the topic, you may ask, right?
Okay.
You directly mail me, I will read out that one, I will reply that one. So that is atoms of what? Different element. Atoms of what? Different element. Atoms of different element. Point number 2. Point number 2. What is the point number 2? Atoms of different elements. Then point number 2. Same mass number. Same mass number. Here is mass number. Third point. Different atomic number. See? Different atomic number. Okay. This is.
But if they're different elements, wouldn't they anyway?
Yeah. Correct. Iso means same. Bars means mass. Bars means mass. So mass number. So mass number is same, but atomic number is different. Is it okay?
Yeah.
Example we are writing. What are there? Argon. Argon is 18 and its mass is 40. Then potassium, its mass is 19, but it is how much? 40. Calcium, mass atomic number 20, but mass is 40. So you see, one is the argon is atom of the element argon. Potassium is the atoms of element potassium. Calcium is atoms of element calcium. Yes or no? So
Yeah.
we can write they are atoms of different element. Atoms of what? Different element. Atoms of different element. Yes or no?
Yes.
Atoms of different element. What is there? Same mass, but different atomic number. Yes or no?
Yes.
Different atomic number. So that is what they are called. They are called isobars. Can you be able to understand this one?
Yes.
Okay, good. So this is the topic. What other things we need to study? Okay, can I erase this one?
Yeah.
Okay. The next topic is we need to study relative atomic mass. Relative atomic mass. Okay. So if you talk about relative atomic mass, little it is the bigger topic that won't be finished today. It will take time to finish relative atomic mass. Wait. See, possible. Stay tuned, please. I'm checking the book. Firstly, I need to go. That is, I'm checking your syllabus because it is there in your curriculum or not.
Okay.
Chapter is what is there? Atomic. No. There is the atomic structure is there. What atomic structure? Page number 24. Let me go page number 24. Yeah, I got this one. Is there? Yeah, it is there. It is the relative atomic number is there. Okay. Okay. So if you talk about the relative atomic number, okay. So it is average of, they are saying it is average of It is average of all the isotopes of, it is the average of all the isotopes of elements. Okay, all the isotopes of elements. Okay, so what is the relative atomic number? It is average of all the isotopes of element. Okay, getting my point? Okay,
Yeah.
so suppose the hydrogen is having 3 isotopes, so you need to calculate the average one, so that is what relative atomic number will come. So how can you be able to solve? Let me try to do the here they didn't give in this problem in this book.
So the relative atomic mass is the mass that's in the periodic table, right?
Yeah, that is you are saying correct one. But how that is correct calculated? That is calculated by the average atomic mass.
Average. Okay.
Okay, that is what
Okay.
calculated. So, Mihika, if you don't mind, we will study this topic in the next class. It will be more easy to you to study in the next class. And then this is the last topic here in the relative atomic mass. Then we will start the, which chapter is there? Let me check the another chapter. Next chapter is the periodic table is there that we will study. Okay, this is the last topic. Some numerical problems are there that we will solve, and then we'll go for the next chapter, right?
Okay.
Okay, bye. Take care.
Bye. Have a
Bye.
nice evening.
Okay, bye. Here is good night, not the evening. It is good night.